finishing up our fire suppression systems. You will get your grades at the ending of the period today. But right now, what you are going to be able to do is reward yourself and your group members for their efforts and contributions that they had during the project. So, you can view it any way you want, but I'm viewing it in a positive light. I'm going to reward my group members with what they brought to the table. So, before we hand the sheet out, I want to explain, first, this is an individual thing. You're not needing to really speak with anybody else in the group. No one in your group is going to know what you did, because this will be a collective whole, and you just have to trust us. I've done this many years now with this thing, this grading system, and no one will ever know. It's anonymous, and trying to just pay attention to what you need to do. So you're grading your group members and yourself on three different categories. Level of participation, overall participation of brainstorming, working, and being part of the group on decisions and involvement. Level of work contributed. This is the actual substance of final project between the building and the paper. So, great, if someone was really, really excited and it was always there, but when you look at the paper and the project and they're not in that at all, well, then that'd be low. If they're involved in a lot of that and actually helped create something, then great. They should get points for that. And then, in general, are you a good teammate? Are you a good team member? Level of cooperation, the cooperation shown by each group member to form a smoothly working group was, and then you give the score. So, i.e. they did not fight amongst each other, willing to listen to others' ideas. This is how this works. This is very simple, but I can see it's very confusing if you don't do it. First, your name. Need to write it. I know you know your name, but you got to write yours. So my parents named me Mr. Gussie, so I'd write it over that. Okay, don't leave it blank. Happens all the time. It's blank. Then you got to put other ones. So I have Slippy and Slappy and Uber Smithsonian-ish. She's so lazy, I tell you. So, now I got to give grades. Now we're going to show you all your group members in a second. But you are grading based on how many. So if you had 5 in your group, 4 in your group, or 3 in your group. Most of you have 4 in your group. Please, we don't need side conversations. You're going to mess this up, and then you're going to lose points for yourself. If I have 4 people, what I'm doing is writing 17 for every one of these columns, because I have 4 people in my group. If I have 5, I'd write 21. If I have 3, I'd write 13. There are a few groups that handed in their papers without someone's name on it because they were not involved or here at all. If that's the case, then that's how, she didn't show up, there's only 3 people in my group. Okay? But that has to be something that your group committed to. And only 3 or 2 groups did that. So for the most part, it's who you had in your group. Then, I get to distribute 17 points. No fractions. So what have I done with the points? What have we done to you? What do you have to... Let's say everyone worked really hard together and towards the project. What's up with my numbers? You're not going to be able to give everybody the exact same points. Usually someone gives a little bit more. You feel like you could reward them. If you truly feel like it was totally balanced, then you got to make a decision how you're going to distribute that. So maybe I'm like, you know what? For participation, I wasn't around a lot. I was at tennis or something like that, so I'm going to give myself a 3. So I have 14 more points. Slippy, hard worker. Very hard worker. I'm going to give them a 6. That's 9 more, so I have 8 more. And maybe Slappy got a 5. So now what, I have 4 left. Did I do that right? No.
That's 19.
Yes. Well, that's 18. So there's my 17. Okay? But work. I worked. That project's all me. I'm giving myself an 8. Okay? Well, now I only have 17 more points. I only have 9 more points to give out. So maybe I'm like, yeah, but everybody else kind of contributed. Great. Maybe. I don't know. If you're going to do this, first off, wow. That's good for you. Wow, you had a tough 10 days. Additional comments needed on the back. You better be flipping that sheet over and explaining why you're giving yourself 17. Either the first statement is, I'm not good at math, or you need to explain all the things of what you've done, just as an example. So, I mean, this is not uncommon. This is unheard of. Usually there's something that people are giving points off to. But at the ending, what you're going to do is then you add up each one. So as I've asked, you should, and it's not just for this, you need a calculator just to make sure. Please don't make mistakes on this. If you do, it's only going to hurt you on here. You add them all up. So you have numbers here. Okay, so for example, Slippy has 9. They only have 9. Okay, and they have 8, and so on and so forth. We still ask you to give yourself a grade. It's giving us context. I always find it really funny when people kind of give everybody grades, and let's say they all have 13s and 12s, but then the grades are like A, C, C minus. I'm like, whoa, wait, if everyone's score is the same, we don't understand, so you might need to give a little explanation. If anything seems out of whack or you're kind of going crazy on a score here or there, a short comment on the back would be great. Again, it's not going to come back. They're not going to find out. She's not going to find out what you said. It's all very anonymous, and believe us, when the points all come together, it's great. But we look at this as you being, you are rewarding the work and the effort, okay? So what we'd like, I'm about to put up a sheet, the screen that had all your group members on in the beginning. And we will repeat this a couple times. We need your mod right now, so this is 11, 12. You're going to write BG or N, and that's going to be based on whoever graded it. So that'll be on the screen in a moment. What's the last? Oh, group number. Is that what you want, Mr. Blackford?
Yes.
Okay, so that's what you put in the corner. So this is the groups. Just understand. So in the upper left, there's an open spot. Please write 11, 12. Write your group number. Let's just say I'm in this group. I'm going to write group 7, and then I'm going to put a B, because Mr. Blackford was my grading teacher for this. It will help a lot in getting this all into the grade book a lot faster for you. Okay? And then you are not again discussing this with, we had this a couple times. This is not the time to, wait, you give this, now give that. Just give the score. You have a right to give the points you want to give. When you first get it, please put 11, 12, your group number, and the teacher, and then immediately make the columns. Most of you are writing 17, 17, 17. If you have a 3-group team, then you're writing 13s. If you have a 5-group team, which I'm not sure if anyone does, yeah, they do, then you're writing 21. You're still distributing the same amount overall of points, potentially to everybody. No fractions. When you're done, we will grab them from you, and then we'll start, and we just have a little bit of notes today. At the ending of the period, we will hand out your projects, and we'll talk about that in a little bit. Okay? So, again, get in the upper left right now, it's 11, 12. Put group whatever, put BG or N, it's all up front. And then under the 3 bolded boxes, please put 21, 17, or 13. 3 times. Need to add those up. At this point, as they say, the hay is in the barn. You just have to reward it. Mr. McCarthy said it all about Coach McCarthy said it. Yeah, write your name right over the name. And you are doing the totals.
left, just below the word fire. Mod 1112, BN or G in your group number. And virtually everybody in here is a group of 4, so all of your vertical columns should add up to 17. If you are group 3, then your vertical columns are going to add up to 21.
Are you going through each group?
8.
Are we going each group? Group 4?
Uh,
17? No, I thought you were going through each group and filling in the numbers. When you're done, we'll grab them from you. So if you are in a group, I mean, just do this as a baseline. If, hey, we all worked really hard, or if you were in a group that everyone really contributed, then you're giving all 4s and 1 5. I mean, that's kind of a good starting point if you have to try to make this up from scratch. You're like, I have no idea what to do. Go off of that. So 4s and 5s are in the middle. If everyone was getting the points. Okay, well, this person did more. Okay, now start increasing or start decreasing. To me, I wouldn't start from 0 each time and going, okay, I'm giving this much. I'd start from the middle and then go up or down. I think it would go faster for you.
Mr. Winkler, are you done? I don't want to unfold 65 pieces of paper. I'm mad. I'm sick. Also, again, if you want to make some clarification, because this is why I graded myself or one of my partners so high, just write that on the back. Or conversely, somebody got a 3 total, and you want to justify that as well.
And once we have that done, need a calculator. We're going to just do a little bit on that note sheet if you don't have it. Get that out, and we'll get started. All right, we're finishing up, I hope. If you have it, we need to grab it. I can grab it if I'm close to anybody else who's in the sheet. You done?
Once again, in the space, just below the word fire, right, 11, 12, that's what mod we're in right now. Either a B, a G, or an N for the grading teacher. That's not your tour. And then also include your group number that is no longer posted on the projector.
Yeah. It's 11, 12. Yeah, I know. I do 6. Oh,
Hey Hunter, how you doing?
Okay, we're gonna get going, please. I'll give you a little time to be able to look at your project at the ending of all this. So, solutions and concentration. Here we go. Pretty laid back today. We're going to just talk about 2 ideas that you will be able to perform mathematically quite well. Okay, we're ready, please. We got to get through it. So, the solutions 1 is due today. If you'd like to hand it in up here at the ending of the period, you definitely can. We just have the end of the period. We have a B, G, or an N. Fine, you choose the one I want. You can put it in up here. So, all right, concentration. If I asked you to make me some really great Kool-Aid, most of you probably would not. Most of you would probably not be cheering as I am like pouring more and more water. You're not like, yeah, more water, pour more water. It's not the way. You're going to take the tub and just be like, dump the tub. I don't care if it's all chunky red solid on the bottom. It's the way I like it. I like to chew my Kool-Aid. Huge. Don't knock if they try. No, that's what it is though, right? But it's the amount that we put in over the volume. So I have something different. I have a fish. You can name it if you like. My kids won a fish. It was a betta fish, and they call it lava, but I have to take care of it all. So one night I'm going to buy another betta fish and really see if 2 betta fish fight in a small tank or not.
Do it. They do. They kill each other.
Or I'll buy 3 fish and put 2 together, and then if something bad happens, I can put the new one back. I don't know. So I have fish in a certain volume, okay? First, you do need to know one conversion, big time. How many liters is that? That is 1. You need to know there's 1,000 mils in a liter. You'll have to know that while we're working on this. And there's not a lot to write down in the beginning. This is just kind of background information. So what if instead I talk about concentration with fish versus my volume? So I have 1 fish in 1 liter. Great. Well, I could say I have a 1 fisher, if I wanted to name it that way. Like, hey, that my concentration is 1 fisher. Sweet. Whoa. What just happened to my concentration? Well, now I have 2 fish in the same volume, so it should make sense that I have 2 fishers. So my concentration doubled. Same volume. You didn't think it could happen, but it did. There's 4. So now what happened to my concentration? Well, same volume, but now I have 4 fish, so I have 4 fisher as a concentration. Let's keep going. Let's get crazy.
Whoa.
So now I've increased volume. Okay, not so good in the world of Kool-Aid. But I've also increased my fish. So if this is 20 fish over 5 liters, what's my concentration? Still 4 fisher. No, it can't be the same. It is the same because it's a ratio, right? That's all it is. It's a ratio. Do I have more of that? Yes, but it's in more of a volume. And that's what we're going to be working on. So concentrations is all about a ratio. Do I have more in theory, but as in space and in volume, it's all ratio based. I have the same concentration. Okay, well, whoa. If I flip it from fish to moles, all of a sudden you'd be like, now I don't understand. Why do you always have to change it to moles? Well, if I had 2 fisher, 4 fisher, and 4 fisher, now all I would have, instead of fish, I'd have moles. We call it 2 molar, 4 molar, and 4 molar. So it would be the same. So what do you call a tooth in a liter of water? 1 molar solution. Woo! I'll be here the rest of the week. Answer me this. I packed a bunch of moles into a little container then. Looking at that, without writing it down, what's the molarity or molar which we're going to call a molarity. What is that? It's mathematically possible.
Oh, it's 24 more. No, it's 32 more.
I put 8 here. I have to put 0.25. So 8 over 0.25 is 32 molar. Okay? So that's what we're going to be working on, okay? How much stuff over the volume. That's all it is. So we're going to make solutions. It's a little freaky. If you didn't see that, we're taking solutions and then we're going to dilute them and do all sorts of weird stuff. So let's talk about it. We're going to be talking about today a little bit about what does it mean to be concentrated or diluted. So if you want to dilute something, it would not have as much of the solute versus a lot of it. So that could be watery. And then we'll talk about that later. So, all right. So underneath or to the side of molarity, it's capital M. You can write either one. I'd actually write both. But we're going to talk about, in terms for the math and everything else in chemistry, it's moles of solute over liters of solution. Just like what I've been saying, the amount of stuff you have in the volume that you have. So simply put, it's big M equal moles over liters. What is nice about this equation is that it has all of the units within the equation already. So it's like, oh, what unit is that in? It's liters. What's that in? It's already in moles. It's moles over liters. It's the amount of stuff over the volume. It's your sugar in your water that makes the concentration of your Kool-Aid. Whatever you want it to be. Okay? Now, you do not have to write this down if you don't like this. If you are good at maneuvering this, that's fine, but this is utilized quite a bit in different kinds of math classes and whatnot. So it's the relationship of that, right? So if you want to solve for liters, you divide moles over molarity. If you want to solve for moles, you cover that up. It's molarity times liters. If you want to solve for molarity, you take moles over your liters. So if you like that, that's great. You don't have to write that down if you don't want to, but you definitely can. So we're going to do a couple problems, show you how this all works. In chemistry, you do this all the time. I mean, you can think about all the labs that you probably always kept asking, what the heck does the M mean? It's the concentration of our acid. It's the concentration of our base or our salt or whatever. It's how much stuff we put in to the amount of water that we have. And that's called molarity. Okay? So here we go. Let me show you how we start this problem. All right, so it says how many grams of NaOH are needed to make a 1.4 molar solution in 465 milliliters. So we are doing a molarity problem. So with molarity problems, there's only 3 variables. You have to be given 2 of them. So this math is very manageable. You just have to understand where things come from. And to be honest, I'm doing harder problems than sometimes that actually exist. Sometimes you're just given 2 numbers, you divide them or multiply them, and you're done. So let's talk about what we know. I know I have 1.4 molar. It says how many grams. Okay, I don't see the word grams. What else have they given me? They said I have 465 milliliters. I need liters. So what am I going to write? Instead of 465 milliliters, 0.465 liters. So I don't know moles. This is it. That's the setup. Yeah, but it asks for grams. Got to remember, grams and moles we can come in and out of. And if you're just like, oh, I just never liked that, got to give it another chance. So 0.465. In this first one, I'll do a little bit more, but eventually you are going to do some without me, hopefully. All right. I'm in moles. I need grams. Robert, your time to shine. How, in general, what do I need to get from moles to grams? What do I need? What do I need to use?
From the 0.651.
Yep, I do need that.
Gotta get grams.
Yep, I want to get in the grams. Hey, I'm going to even give you a hint.
Just put moles of yeah, NaOH. Okay, and then under that, go over there to the board and add them
What's that thing called?
The periodic table.
You are on fire. Where do the moles go? Top or bottom? Whatever's on the top first has to go on the bottom. So I have to add these up. Good work. I'll help you out. Na is 23, oxygen 16, hydrogen's 1. That's a nice 40. So I just multiplied. So I would need 26.04 grams. Many problems will just ask how many moles would that be. But it's not a realistic life question. How many moles? You don't weigh moles, you don't measure moles, you don't buy things in moles. You buy things and weigh things and work with things in grams. So at some point you would need to know how many grams you would need to make this solution. So we're going to be making solutions. So that is how we do that problem. Okay? Let's do a little comparing and contrasting then. One more. It says how many liters? So now I want to find liters, and they gave me molarity. So if I want to find that, that means I need to know both of these. What did they give me? They gave me grams first. So what do I need to do to that? I need to get that into moles. So I'm going to start a new problem here. How do I know that I have to put the grams on the bottom this time? Because they were on the top in the previous part, right? That's all. If you're in grams, you're in moles, and you want the other one, you're using the molar mass either way, either multiplying or dividing. So what do? 6.9 plus 35.45. That's all from the periodic table. So it's going to be a small number. And that's just from the periodic table, and I got this. Actually, I'm going to round. Sorry, if you already wrote, I'm going to round up. And that's just one Li and one Cl. So what do I do with that now? That can go here, and the molarity has already been given to me. So let's put it all into play. I have 0.46 molar. I have 0.0815 moles. And this time I'm solving for liters. So if you want to use that triangle, that's great. The pyramid, you don't have to. A lot of you should be pretty good at reorganizing, but if I want to solve for liters, that means I have to take my moles and divide it over my molarity. I'm going off of memory. Is it like 0.177?
Yeah.
Okay. And that's liters. I don't question what it's in because the unit is in the equation. It's really nice. I don't have to worry about units at all. I just copy down whatever unit was given to me. If I was asked for milliliters, what answer is it? It's not 0.177, it would be 177, right? Be 177, just so we know. So that's how we do concentration. To kind of just echo this for a second, so if you don't have that, I will go back up, but I wanted to show you something. So here's a little simulation. We'll do this really fast. It's about stuff over volume. So what this is a meter that says concentrations, okay? So right now it's 0. If I take this drink mix and put some solid in there, the concentration goes up. It shouldn't shock you that it continues to go up when I do that. If I let some water out, why did the concentration not go down? It's a ratio. Think about it. If that was all Kool-Aid, all tastes delicious, and then you poured half of it out and then taste the next cup, you're not expecting it to be like, oh, why is it all watered down now? It would taste all the same, right? Because all of it was dissolved. But what if I add water to this up here? That should go down because now I'm adding more actual liquid, right? And not the solid. So now I gotta add more.
It's turned dark red.
Go.
Going.
And what you'll notice, what did we learn the other day? We learned about things called saturation, soluble. If at some point you can't hold anymore, watch. It says saturated! Exclamation point. And I don't know if you can see this, but on the bottom there's starting to be solid showing up. And look at it, concentration's not going up. Why? Because nothing else is dissolving. But if I let it out, nothing should happen.
Overflow.
If I do this,
Yeah, overflow.
Oh, use the ball stuff in the bottom.
eventually then dissolve. So in the beginning, you notice it wasn't moving because nothing was dissolving, but then eventually it did. So it's all about ratios. Okay? Don't write this down. When we make solutions, beakers and graduate, like beakers, like people always measure on the line, be like, hey, I got it exactly on there. Got to realize that beakers are plus or minus 5% error, which means in like a 500 milliliter container, you could be off by 25 milliliters. That's not really good if you're trying to be accurate. Graduated cylinder is better. It's 5 milliliters. But then there's these things called volumetric flasks. So when you want to make a solution, more accurately, use a volumetric flask. In a volumetric flask, what's crazy about it is this whole like graduated cylinder, hey, I can measure 10, I can measure 30, I can measure 50 milliliters. This measures one volume only. There's a line right here, and this says 1,000 milliliters. This measures 1 liter exactly. Only one. Well, what happens if you want to make more? You could go 2. I had one that was a 4 liter once and it broke. The top snapped. It was awesome. You had like use 2 hands, like churning butter. Maybe you want to go smaller, 250. It's all to that line only.
Why is it anyone different than a beaker?
Because it's just more accurate. Because there's only the lines on there are just kind of thrown on there. They're not as accurate. Also, where you're reading it's on a beaker is like that wide, and here it's into the stem, so it's much more accurate where the final volume would be. Or you might need 5 milliliters. Look how cute he is. Look at, yes you are. Yes you are. It's my favorite. Little 5 mil. The cap is bigger than the beaker itself. So what you do, because you're going to have to make a solution on Friday. Don't worry about a meniscus, by the way, you've probably learned about meniscus. It looks kind of like a contact lens. You're going to see it in a second. The reason why it actually goes up is it's attracted to the sides of the glass. It's attracted to the glass. Right, okay. So this is what a normal meniscus looks like. And then we're never going to deal with mercury because if it ever breaks, we got problems. But you have a reverse meniscus because it's actually more attracted to itself. So that looks kind of weird. But this is how you're going to make this. So actually, you put a little bit of water in first. Okay. Then you're going to put in your solid. You should fill it about halfway. If you're like, oh, put it in the solid, fill it all the way to the line. First, when you stir it, literally nothing moves. That's why, like in a washing machine, it doesn't fill all the way to the top and then try to wash your clothes. Nothing's going to shift. So you only go about halfway so you can agitate it and move it. If that doesn't work, you can also cap it. These caps are on here, and then you can go up and down, but it doesn't mix nearly as well as stirring it or swirling it. So you swirl it, and then once it's all dissolved, because the volume actually goes up when the solid goes into solution, dissolves, then you fill it up to the line. This is an actual, real look instead of a cartoon. So you put the solid in, fill it halfway, and then that is what the meniscus will look like. The bottom of that meniscus is right on the line. If you go over it, you ruined it. You got to go right on that line. It's like, oh shoot, I went over. I'll just dump some out. It already has some of the solute in it, the stuff that you're dissolving, and you would dilute it or not have the exact same volume that you want. And then when it's all done and it's on top, you cap it, and you go up and down, and it's cool because you'll see it all swirling and mixing, and eventually it's all one solution. And we'll use volumetric flasks for this. Okay, so again, just another image of that. But what if I have an amount, and I'm like, oh shoot, I have a really concentrated amount, but the machine I'm using or whatever, I need a lot less of that. Like I don't need it that concentrated. How do we dilute it? So what you would do, and we're going to work on this on the next part, you take what you need for your concentrated part, you throw in the amount, which we'll talk about how much do I need, and then you'd fill the rest of it with water. Like that should at least make sense. Hey, I want to dilute this. Add water. Okay? Well, this is how we do this. Don't write any of this. Okay. So dilution. So the side of the next underlined word. What I'd like you to do, don't put C's and D's. Please put 1s and 2s. So it's M1V1 equals M2V2. Please write that to the side of the title. M1V1 equals M2V2. And we have concentrate and dilute because that'll help us with what we're about to go over. Okay? So this is the first problem on your sheet, and right away this will help you understand this. We buy things in concentrated amounts. It's cheaper. If you're going to pay someone else to dilute it, that's fine, but most businesses don't want to do that. Like, we're more than capable of diluting our own stuff. So let us just buy the most concentrated acid. We'll dilute it ourselves. You also have less containers, a lot less. Like, you can have a concentrated acid here and make liters and liters of diluted acid then. All right, so here's the first question. Concentrated phosphoric acid is 14.8 molar, so that's really concentrated. What volume of concentrate is required to make 25 liters of a 0.5? So I want a lot of a very diluted acid. This is the amount of math you need to do. Okay, so it's M1V1 equals M2V2. So I have a concentration of the concentrated stuff, and then I have the volume and the molarity of the diluted. So these are grouped together. So this is going to be my M1. Okay. I don't know the volume I need, so this is V1. M2, V2. That's it. I want to explain what the numbers mean, because once you realize the answer and how that works, everything will make more sense. So what do? You multiply and divide. Right? You are trying to take a little bit from the concentrated, and then you're going to dilute it. So I take it out, I put it in a new container. 25 liters, that's a ton. That's a lot. Of 0.5. Like for your fire suppression, we made 10 liters of 1 molar, and that looked crazy in the back room. We had all these big, huge 2.5 liter containers full of acid. And it looked like a lot. So you take 0.5 times 25 divided by 14.8, and you get roughly, let's do that. I think, is that right? Yeah. Now, this isn't what it's asking, but I just want you to completely understand this. This is of the acid. So I'm going to drop that much in a 25 liter container, let's say. What's the rest in my solution? What's the rest in my diluted acid? If 0.8, so 845 milliliters of it is the really strong acid, what's the rest of it? It's water. So how much of that is water? Well, it'd be what? 24.16555. Why is it that? Because this is a 25 liter solution. I just want you to visually understand that. Okay, so let's take a different look at this. We only have 2 more problems. We're doing really well. So this one, you have 75 mils of concentrated HF, which is 28.9 molar. If you were a big Breaking Bad fan, they used that in the first season to get rid of a mammal in a bathtub. And it ate through the bathtub. You need 15. You guess it's a mammal? It's a mammal. You need 15 liters of 0.1 molar HF. Do you have enough? Okay, this is a different kind of problem, but the same exact math. So let's take a look at this. So what it's saying is, hey, I want 15 liters of 0.1. Can I dilute it? So this is still M1V1, but let me show you how this works. So this is 28.9. This time I'm going to do this once. That is M. This will make more sense, though, if you write it like that once. That is molarity, moles over liters. And I have 75 milliliters. So just to be accurate, you could keep it the same. You need the same volume. So I have 15 liters here. I only have milliliters here. I gotta change one of them. So I'm going to change that one. If I multiply these two units, what's left? Moles over liters times liters. What's left? Moles. Moles is the amount of stuff. Get past all the weird word. It's how much stuff I have. So if I calculate that right now, what you have is 2.1675 moles. That's literally how much sugar you put in your Kool-Aid just now. What it's asking is, do I have enough to make that? So the question is this. Do I have enough? So I'm going to put, 0.1 molar, I can't find all this, times 15 liters. Well, 0.1 times anything, just a factor, you just slide it down. So it's 1.50 moles. Do you have enough to make it? You can think of this as the amount of actual compound, amount of stuff you have. Do you have enough to make that? This is how much I need of the stuff. This is how much I have of it. So yes, this is greater than that. So yes. Yes, I can. Obviously, 2 exclamation points with a smiley mouth is appropriate in this situation. So, what I'd like you to do, answer the last question. And you can keep it in milliliters. So, what is the volume of 15.8 molar HNO3 is required to make 250 mils of a 6 molar solution? If it starts in mils, you can end in milliliters. So, leave it in milliliters, please. We'll answer this last question. What I'm about to do, it's not due until Monday. We have a little worksheet that works on that. All of the answers are on the bottom of both sides. If you only write the answers, clearly that's not really a good idea. You need to show the work. But we're showing the work in context of molarity, moles, liters, that kind of stuff. Okay? So, I'm going to get this out to you, and then we'll talk about your groups. As you're finishing up, this should have been your setup. Every time we show you this stuff, those of you that aren't writing units and things, that you're not understanding that that's by putting it in the equation that's showing your work, and needing the units are an extreme importance in understanding what the numbers mean. Without the units, we don't know if those are volumes or molarities or whatnot. So I set it all up, and you should have gotten roughly 95. If you did, way to go. So on your sheet, you have answers on the bottom, on the front, and the back. So you work through it. We're just giving you different situations that you can go with. Okay? Terrific. Hopefully you got that. I'm moving on now.
What'd you get?
95. So, we're about to hand out your projects. We graded it. By the way, my fault. It was out of 52, not 50, because we added the journal and some of the things. There are a couple of groups. It will not have a grade next to your journal, which is your log, because you didn't give us access. So we've hit request access. You need to give us access. You'll know in a minute if that's including you. So if that's the case, you need to grant us access so we can actually see the log in the journal. You guys, if you'd like to hit, we can probably hit power with this one. So we're going to hand these out. If there's any problems, any issues, please let us know. Listen, guys, there's a couple groups.